Welcome to Maths for All. I'm Aisling Flynn. This is Number Patterns 1.3, the general term. So the general term is called Tn. N refers to the position of the term in the sequence and T is for term. T1 is the first term of the sequence, T2 is the second, and so on. And Tn is the nth term of the sequence, so it refers to any term of the sequence. Here's an example. The nth term of a sequence is given by Tn equals 3n minus 4. Write down the first three terms of the sequence and also T20, and then explain why the sequence is linear. So T1, if you follow what we're given, 3n minus 4, you replace the n with the number 1, so you have 3 1s minus 4, which is 3 minus 4, giving minus 1. So the first term of the sequence is minus 1. Repeat that then for T2. So now you're replacing n with 2, and you get 6 minus 4, which is 2. And repeat once more with T3, and you get T3 equals to 5. And it works also for T20. So replacing your n with the number 20, you get 60 minus 4, which is 56. Okay, so your pattern is minus 1, 2, 5, and so on. And you're asked to explain why the sequence is linear. The sequence is linear because there is a common difference between the terms. So if we examine it, the difference between minus 1 to 2 is plus 3, so you have to add 3. And from 2 up to 5, you have to add 3 again. Okay, and we could look at more terms, but we suspect that they'll be the same. Okay, so in this case, the common difference, D, is equal to plus 3. So you add 3 from term to term. Okay, so how do you find the general term Tn? Examine the differences in the sequence by completing the table below. So firstly, there's our sequence 7, 10, 13, 16, 19. We start off with a table here. So the first term is 7. The second term is 10, which is 7 plus 3. So we see our common difference is going to be 3. The third term is 13, which is 7 plus 6, or 7 plus 3 plus 3. So you've added 2 3's to the number 7. We continue there. 7 plus 9 is 16. That means you've added 3 3's, so 7 plus 3 3's. And 19 is the next one. That's 7 plus 12. That's 7 plus 4 3's. Okay, so what do we notice here? Can you see that when you're on the second term, so n is 2, you add 1 3. When n is 3, you add 2 3's. When n is 4, you add 3 3's. And when n is 5, you add 4 3's, and so on. So this number here is 1 less than the n value. If you like, for the first one, you could say that 7 is 7 plus 0 3's. Okay, so keep that in mind. The number of 3's that you are being added on is 1 less than the n value. Okay, so using what you have learned from the table, what is the 10th term of this sequence? So T10 will be 7 plus 9 3's, so 1 smaller than 10. Okay, 7 plus 9 3's is 7 plus 27, so the 10th term would be 34. Okay, bringing that forward, the general term Tn, we can put what we've learned into a formula, and this is in your formula book. So the nth term of an arithmetic sequence, Tn, is equal to a, which is the starting number, plus n minus 1. So there you have it, multiplied by d. So the n minus 1 refers to 1 less than. So if you recall, T10 was equal to 7 plus 9 3's. Okay, so 1 less than the n. And so this applies to all arithmetic sequences, and this formula is in your formula books. So Tn is the nth term, A is the first term, N is the number of the term, and D is the constant difference. And this is in your formula and tables book. So let's look. Find an expression for the nth term of this sequence. So an expression means a little algebra term that describes all of the terms, okay? Little algebra sentence that describes all of the terms. And the nth term, of course, is Tn. So how do you do that? And later we have to find Tn and T20. So we start with our formula from the formula books for arithmetic sequences, Tn. We look at what we're given, 7, 11, 15, 19. So A is 7, that's the first term. And the common difference, if you do some subtractions, you see it's 4. So 4 is being added each time. So that's what you do. You replace A with 7 and replace D with 4. Okay, then we're going to multiply out that bracket. We get 4n minus 4. And then we're going to add up the bits we can. So we have 4n and 7 take 4 is 3. So Tn equals 4n plus 3. T10, then you just substitute in for your n, which we've done before. So 4 tens plus 3 is 40 plus 3, which is 43. And T20, repeat, but this time n is 20. We get 83. Okay. Here's another one. Find an expression for Tn of the sequence 8, 5, 2, and so on. For what value of n is Tn equal to minus 34? Okay, so just looking at that sequence there, it's decreasing, it's going down. It will go below 0. You will continue into the negative numbers. Okay, so let's have a look. So to find Tn, you write down your formula from the formula book. Looking at your sequence here, A is 8 and D, well, what's happening in the numbers? They are falling by 3 each time. So D will be minus 3. Okay, so substitute those numbers in. A is 8 and D is minus 3. So you're multiplying the bracket there by a minus 3. So let's see how that's done. We get 8 minus 3n. So that's the minus 3 by the n. And you get minus 3 by minus 1 gives me plus 3. Okay, so just take care around the negatives. And 8 and 3 give you the 11. So it's Tn equals 11 minus 3n. Okay, so that's the first part done. We found an expression for Tn. Now, for what value of n is Tn equal to 34 or minus 34? So what we do there is you take your expression for Tn and you put it equals to minus 34. This question is asking you to solve for n. So which term in the long sequence is minus 34? Which position in the line of numbers is minus 34? So you've got a simple equation there. We start by taking 11 from both sides. Okay. Simplifying on the right, you get minus 3n equals minus 45. You divide both sides by minus 3. Okay, and we get n equals 15. Okay, just a note here, you should always get a positive answer for n. Okay, because n is just a number describing the position of your term in the line of the sequence. Okay, it doesn't go backwards. It always goes forwards. So n should always be positive. Okay. And so you can say that T15 is equal to minus 34. Okay, look at this question. How many terms of the arithmetic sequence 45, 43, 41 are positive? Okay, so what's this mean? You can see that the numbers are decreasing. They're going down. Okay, they are positive, but there will come a time when they reach 0 or pass out 0 and enter into the negative numbers. Okay, and the question's asking how many are positive. Now, This question can be asked through common sense, every second one, or it's falling by 2 each time and you can figure it out. But let me go through the procedure with the formulas. So first thing I'm going to do is find an expression for Tn. So A is 45 and D is minus 2 because they're falling. Okay, multiplying the minus 2 by the n minus 1, and this is what we get. And Tn is 47 minus 2n. Okay, now the question arises, when does the sequence get to 0? Okay, so that's what I do. I put it equal to 0 and I solve for n. So taking 47 for both sides leaves me with that. Divide both sides by minus 2 to solve for n. And I get n equals 23.5. Now, n can't be equal to 23.5 because it describes a position in the line of numbers. It's either 23 or 24. Okay, so what does this mean? The numbers are falling. The sequence reaches 0 between the 23rd and the 24th term. Okay, so none of the numbers is actually 0. The 23rd term is positive and the 24th term is negative. So one is slightly above 0 and one slightly below. Okay, and to answer the question, how many were positive? The answer is 23 terms were positive. Okay, so T4 of an arithmetic sequence is 11 and T9 is 21. Find the values of A and D and hence find T50. So looking at this here, normally to find D, we would subtract terms that are side by side in the sequence, but we have T4 and T9, which are a good bit away. Okay, what can we do with the information given? Well, firstly, let's take our arithmetic sequence formula. The question tells us it's arithmetic. First thing I could do would be to take T4 and use 4 for n. Okay, that's A, I don't know, plus 4 minus 1 times D, which we don't know, and put that equals 11. Its value is 11. Okay, I'll just simplify that a little bit. We get A plus 3D equals 11. Okay, right now I can't proceed any further with that. But I'm going to repeat that now with T9 using 9 for n. Okay, and we know the value of that is 21. So simplifying, I get A plus 8D equals 21. So there I have two equations, A plus 3D equals 11 and A plus 8D equals 21. So two equations with two unknowns, that's A and D. This is solvable, and it's solvable by simultaneous equations. So when you have two unknowns, you need two equations, and then you can solve them by simultaneous equations. I'm going to ask you here to pause your video and work that out, and the answers will appear in a moment. There's your answers. Check, did you get that right? Okay, so now it's time for you to do it. Do your quiz called Number Patterns 1.3, the general term, and your written exercises of the same name. Here's a small glossary.